Hey Jarvis, can you tell me about who you are?
I'm Voice Speaker.
A smart speaker assistant created by Alex Dixon.
I'm designed to help you with various tasks and answer your questions through natural conversation.
Think of me as a voice assistant you can chat with. I try to keep things simple and conversational, just like we're having a regular talk. I'm here to make your life a bit easier by providing information, assistance, or just having a friendly exchange whenever you need it.
Welcome back to another one of these, building an LLM Smart Speaker. So that was a little demo of what I have so far. That's actually the kind of entire round trip of the software stack of what it needs to do. It was taking the voice input from the PlayStation DS4 microphone of the controller. Then the Raspberry Pi was processing that, transcribing it, the audio into text, sending the text to an LLM, getting a response back, and then turning that into speech again. There was a little bit of latency there, but this is the first, the first time I've got it working. So I'll go through all the details and show you what I've got. So before we start, I started this project called Oi Speaker. This is on my GitHub. You can get it from github.com/polymonster/Oi Speaker, as in you're saying Oi to the speaker. That's what I think I'm going to call it for the time being. Sometimes you need a name. And that's the name of it now. So all the code's on GitHub, what I have so far. I mean, it's not super complicated because I'm using external dependencies and they're getting me a lot of the way to do through it. So the code itself was actually just quite like glue code, basically. Just bringing together some libraries and gluing it together. But I was doing it myself and trying to do it from scratch as well. So this is just the output from the Raspberry Pi. We run Python speaker.py. It greets us, it says oi oi, just in text, so we know it's happened. And then we have information about the audio devices. So I use DualSense controller for the microphone input and Scarlett 2i2 USB for the output. So we have separate input and output devices, which will be useful in future anyway. Then the wake word happens and it says "hello mate" in the logs. That means it has acknowledged me. And then the next line after that is, "can you tell me about who you are?" That is what I said, and that is the result of the transcription to text. That then gets sent to the Claude LLM, and then the response is this, and that is the response sent in text, and then later the audio would come out of the speakers. That's what you heard on the video. So here's the basic flow of what it looks like and how it works. We have wake, transcribe, LLM, and text to speech. The first stage of it is wake. So open wake word's the first thing that we need. This is detecting the "Hey Jarvis" wake word. And then once we activate that, we can start recording and do more heavyweight processing. So this one came recommended. It's a small neural network that just listens for this particular wake word. In the long run, I want to train my own model for my own custom wake word for this, so that'll be another video that I do. But this one works well for the time being. This was the first thing I did. I started to just write out the code myself manually. I wanted to do this without just asking Claude Code to do it for me. And then I started to bring in some dependencies. In the end, I had to go to Claude to ask for help because I was having trouble with dependency installation. And the problem ultimately was that the Raspberry Pi came shipped with Python 3.13, and a lot of the wheels, which are the packages that you can install for Python, weren't set up or supporting Python 3.13 and only had Python 3.11 versions. So I had to roll back the Python version and I had to install Python 3.11. I put the instructions in the README of the Oi Speaker repository. It wasn't that much effort, but it was just a bit of a pain, and it took much longer than the rest of this project, really. Just getting the initial wake word working took the longest amount of time. To do voice to text, I'm using Faster Whisper, which is an re-implementation of OpenAI's Whisper speech-to-text model, and it's optimized using C Translate 2 for faster inference. So the network architecture itself is a transformer encoder-decoder trained on 680,000 hours of multilingual audio. Designed, it's a faster implementation so it can run reasonably well on the Raspberry Pi. I'm noticing a bit of latency when using this, but I think I can parallelize some of it to kind of hide some of that latency and just get the response time down. So I'm using Claude Platform as the LLM for this, and that's plugged in. So you send the text response to Claude and then you get the output back. I had to add credit to this myself manually, and it's a separate subscription to Claude Code, but it seems fairly cheap, and for this project it's going to be fine. In the long run, I would like to be able to have interchangeable LLM models, so you can use paid services, local ones, or whatever, and that should be all configurable. Finally, once you get the response back from the LLM, I'm using Piper 1 GPL. This is Piper TTS, text-to-speech, and it's installed in Python, Piper TTS. So this one uses a variational inference with adversarial training for speech synthesis, a neural vocoder architecture that generates raw audio directly from text. So this is text-to-speech. It sounds okay. The voices are a little bit jarring because they seem to change across sentences, but again, it's just something that's small and can kind of run on a Raspberry Pi. So I'll give you a little bit of a rundown of the code while I'm here on PC. It's just a bit easier to do it on PC for recording and streaming than doing it on the Raspberry Pi itself. But it's running on the Pi. It should run on PC, because it should be a server as well, potentially, and Mac. So I need to get the Mac and the Linux build works because of Pi, but I need to get Windows and Mac working. Yeah, so let's see what I have so far. I mean, it's only 250 lines of code. We have all of the dependencies, open wake word, Faster Whisper. There's another thing called WebRTC VAD, which is voice detection. That can tells when you're talking or when you've stopped. I might need to have a bit more of a look into that. But there's a bunch of, it brings in a bunch of dependencies. We have some constants which are to do with the sample rates of the audio. There's some utility functions for removing markdown, because sometimes you can get a response from LLM that has markdown in it with asterisks and hashes and things like that for formatting. Stuff about audio device. I had to do audio resampling, which was quite important because the target sample rate for these models are 16 kilohertz, and my audio devices are like 4,400 or 40k something. So audio needs to be resampled. So using NumPy to do the kind of arrays and those kind of operations. There's function to read audio, which just takes an audio stream and it takes this out and flattens it into raw bytes. Some functions to record until silence. There's another variation of that I was experimenting with. Function for listen for wake. So we read the audio, we read audio, and then we pass the wake model the audio, and then it gives us back a prediction and a score. Same things for transcribing audio. We give it an array of audio, we have the whisper model, and then we just say transcribe. So it's dead easy. It's like you're just putting audio into an ML model and you're getting the result back. You're putting text into an ML model and you're getting audio back, or whatever it may be. And then I've got some functions flushing the stream, just because there might be garbage in there when you return back to the start. Query LLM, this is the kind of thing that it seeds it with an input prompt to say it's the speaker, and so it gives you snappier responses. Hard coded at the moment, Claude Sonnet. But you're passing a JSON payload basically to the Anthropic API. And then there's the speak function, which takes the output text and synthesizes it from the voice model. And there's another version of that, debug one, trying to just figure it out. I also added a small utility function, which is a test tone. That was just to test the audio output. And then the main function is just quite a simple loop. We enter the loop, we create the wake model, which is Hey Jarvis. As I said before, I want to train that to be its own custom thing. I'm going to address it as Oi Speaker. So you're like, Oi Speaker, like with a UK garage flavor to it. Old tight selector. Then we init the voice audio detection thing. The whisper model, we pass some parameters in, we create the Anthropic LLM client, we create the voice model, which has been downloaded. This is GB Northern English Mail. All of these things should be configurable, and I'll probably do a YAML config for this. Then we grab the audio device. So the input device is the DualSense, the mic on that. The output device is the Scarlett 2i2 USB. So we have separate input and output devices, and they might have different sample rates. So this is where the resample audio function is important, because we need to make sure that we have consistent sample rate for the things we're passing it into. But that's just the setup, small amount of setup. And then there's just a main loop where we're in a little state machine. We can either listen for wake. So when we listen for wake, that's always running in a tight loop. Then if we detect listen for wake, we enter the chatting stage where we record audio, transcribe it, query the LLM, remove any markdown, and then output that to the speaker. I started experimenting with a little bit of different flow. Like if it ended with a question, we could stay in the chatting state for longer. I think I need to play around with that to make it feel a bit more natural, so you could have follow-on conversation without having to reactivate the speaker. But once you finish a chat, it goes in reset, and then we flush the stream, reset the wake model, and then we go back to the listen to wake state. So that is all pretty basic stuff. All of this is set up as a Pi project, so all the dependencies are in here, so it can be reproducible. In the README, there's all of the installation instructions so far, which I'll try and streamline as much as I can over time. And that is pretty much it, really, where I'm up to now. I can talk to the speaker, it can recognize me, we can have a conversation, and it can send responses. Next up, I need to add more integrations so we can start doing things like home assistance or different skills, and programming the LLM so it knows what you want. For instance, if I say set a timer, it can set a timer, or if I say tell me the football scores, it kind of knows how to respond. That should all be configurable on a user basis, because other people might have different preferences. Then I need to train the wake word to have the custom one of Oi Speaker. And then after that, mainly it's like a case of building the speaker, because it kind of works now. It could be better. Optimization is going to be a big thing, and I'll dig into that. But this is where I got to. I just did a small amount of coding this weekend. Yeah, that's about it. I did that this weekend. I only spent a couple of hours, and I got the whole pipeline working end to end. If you enjoy this, please let me know. If you've done it yourself, also give me any advice or tips. Tell me what you know about. If you want to see more of it, just give me a sub and a like or a comment and anything like that. I've got some more followers recently, which is quite good. So more people. It'd be fun to engage and have a bit more community around it. So let me know if you do enjoy it, and I'll see you next time.